Hello everyone, today I'm going to talk about how likely I actually think the Falcon Heavy is to succeed. And I thought I would use this as a little bit of a hang-up to talk about some basics of reliability and safety estimates. Now, there are a few factors to consider here and it gets a little bit complicated. I'll try to keep it a bit simple, but I'm not just gonna say it's gonna succeed or it's gonna fail, that would be stupid. I'm going to try and estimate roughly how high percentually I think the chance of success is. Now the first thing we could go to would be the success rate of the Falcon 9, which had 46 planned missions so far and 44 successes with 2 heavy failures. So that would give us in around 4.5% failure rate. But then anyone who's ever worked in technology, and especially anyone who has to do with spaceflight, can tell you that early prototypes or first test flights of rockets are not really expected to succeed. I know I bring it up a lot and it might be a bit of a coincidence and draw a slightly skewed picture if brought up too much, but I kind of like it as an example and it really fits here. The nowadays statistically considered most safe and reliable rocket type today started its career off like this. And the knowledge that early test flights are very unreliable actually impact the probability of a Falcon Heavy success in two counteracting ways. Now, of course, this isn't really a contradiction because the considerations we're doing here are quantitative, not qualitative. So it's not really a contradiction, they're just counteracting each other, and one is a little bit stronger and it is more negative. The Falcon Heavy is a first rocket test flight, so it could be expected to fail. But on the other hand, what it also means is that SpaceX overall is probably more reliable than you might think at first. Generally, since early rocket test flights are incredibly unreliable and rockets do get more reliable as they are improved, you can't really estimate the reliability of a rocket just by proportionally extrapolating the previous success or failure rates. You have to take into account that they improve and get more reliable later on while starting off terrible. And the same thing is true for SpaceX overall. They had a failure both in 2015 and in 2016. Then in 2017 they had more flights than in 2015 and 2016 combined and not one failure. And their landings, both at Cape Canaveral and on a drone ship, are also getting a lot more reliable with a roughly 50% success chance at first. And now in 2017 they have been empirically 100% reliable, although you can of course never call something 100% reliable. It might have never failed before, but that's usually just because you haven't tested it enough. And while the launch rate of SpaceX is relatively high for rocket launches, this is still a relatively small sample size. They have launched an overall of 45 Falcon 9 rockets before. One exploded before launch, one exploded shortly after launch, and that is not a gigantic sample size, so any estimate of reliability has itself a bit of an insecurity of a few percent because, well, with a sample size of roughly 50 pieces and, for example, let's say a failure rate of 1%, you could not precisely assess that reliability with that sample size. It would either come out as 0% or 2% or even more because, well, it is probability. It never turns out exactly as it should. That's the pain with estimating probabilities, but by now I would give the Falcon 9 a reliability of roughly 98%. Now the Falcon Heavy is a new rocket type that's being tested, and that of course negatively affects its reliability quite a bit. Then on the other hand, it's not completely new. It is basically a heavily modified several Falcon 9s strapped together. So it's maybe not as unreliable as other rockets when they are test flown for the very first time. Then on the other hand, the project is rather complicated, so there is a bit of a higher failure chance. Now let's first try to estimate the overall future success rate of the Falcon Heavy. It is essentially several Falcon 9s strapped together, and we have a good idea of how reliable those are by now. And these reliabilities or these failure rates essentially add up, not just by adding or subtracting, it's a bit more complicated, but probability isn't that complicated either. So the Falcon Heavy has twice as many stages and 2.8 times as many engines as the Falcon 9, although an engine failure hasn't really caused a Falcon 9 failure before. It's usually been control or fuel tank failures. Still, you could of course, for what estimate, just multiply these probabilities. You could take the estimated 98% reliability of the Falcon 9 and square it, giving you a tiny little bit over 96%. But then there are of course factors that are not just coincidental but affect all stages equally. For example, if one stage of the Falcon Heavy is going to launch in good weather, then so are probably the other stages of the Falcon Heavy, and vice versa. Then on the other hand, the Falcon Heavy is overall a bit more complicated. So I think we can leave this at a little bit over 96% or maybe 97% later on if they keep it flying for a lot longer and get a lot more experience at it. And if we look at other rockets with this kind of reliability, which were based on other rockets before and were mostly slightly modified types of previously flown rockets, then we can see how many of these modified rockets had successful first test launches and get a pretty good picture of the Falcon Heavy's probability for success. And it turns out that oftentimes strapping together or modifying previous existing rocket types doesn't always impact reliability that positively. It might have to do with these rocket types being previously tested under different conditions, so you think they're reliable, but you don't really retest or reevaluate them under the new conditions. So this kind of evens out, and modified versions of previously existing rockets turn out to be about as reliable as completely new rocket types. And so I would leave it at a roughly 70% success chance for the first Falcon Heavy test flight. I would like to go a little bit deeper into the actual system analysis behind this, but that would quickly need a lot of time. Then there's also the consideration that they are going to try and land all the three cores, which of course has a different success chance than the launch itself. That has always been the main focus of the Falcon 9 design, that the main priority would be to successfully deliver a payload into orbit, and the second priority would be landing the first stage. And while these priorities in operation might be a little bit different for a first test flight, the design is intended for an operational rocket, so the design priorities would probably be pretty much the same. So the chance of a successful landing would be a lot lower than that of a successful launch, although landings have become rather reliable, and the landings are at least separate events, so they're not really something entirely new. The stages are going to separate and land each on their own, and they've landed single Falcon 9 stages before, while they have never launched three strapped together before. But then these separate events, of course, each have individual chances of success. So I'll just keep it short, and my rough prognosis will be a 70% chance for the overall payload delivery to be successful, and a roughly 50-50 chance for the entire mission, including all three landings, to be successful. Now this might be a little bit optimistic, especially given that this is a first test flight and it's kind of expected to fail. Elon Musk himself doesn't necessarily expect this to be successful. That's why they put on a dummy payload rather than a functional satellite like some other rockets did. But given that SpaceX has generally gotten more and more reliable lately, and that this is an estimate of chance, not an exact prediction, I think it's relatively safe to give it a 70% success chance. I hope you enjoyed this little look into the factors influencing how reliable you could estimate the Falcon Heavy test flight, or generally rocket launches, to be. If you have any questions about spaceflight or aviation in general, I'm always open for questions, although I might take a while to get around to them. And as always, thanks for watching.